Hey, how do you get good graphics? Dude, the graphics looks amazing. Are you sure this is not an Unreal? Is this even Godot? You're lying. Bro, how did you do it? In my recent videos, I've been getting quite a lot of comments on how my game looks good. Well, it isn't. But I'll show you how I made this free and open source game engine Godot looks like it's made in Unreal. Now, hold up. I'm not gonna say my game looks like it's made in Unreal. It's just some of the comments I've been getting. Camera is shit, but content is gold. You look like that one Indian dude who says he works at Microsoft and wants my bank details to solve a bug on my PC, lol. Awesome and informative video. Dislike. Well, okay, maybe not. To start off, we gotta go back and understand how 3D graphics actually work on a surface level. Almost every graphics engine has 3 steps that it follows to render something: vertex shading, rasterization, and fragment shading. Now, if you're a normal person like me, you wouldn't really know any of that, but it'll definitely help you understand the fundamentals. Essentially, these 3 steps allow you to form a 3D object onto your 2D flat screen with the correct pixels and color. And every object is formed with a bunch of triangles. They can go up to a few hundred to a million, and graphic cards these days are pretty powerful. It can handle millions of triangles in real time. And each triangle can be lit with accurate colors, cast shadows, have light upon them, etc. But this doesn't answer our question to how I make this engine have good graphics, because this engine does all of the things I just mentioned. Except, it still isn't good as Unreal. Now, I haven't used Unreal myself because, yuck, 100 GB download size, plus 20 GB project sizes. I'm sorry, but no.
Hello guys, and welcome to my YouTube channel. I am Raj, and today I will show you how to install Unreal Engine.
So we know that Unreal does its best to keep things realistic. If we break this down, we know that Unreal does 2 things best under realism: lighting and general rendering. Unreal has always been praised for its lighting being absolutely perfect. Its recent tech called Lumen pretty much makes every engine have no competition when it comes to lighting. Then comes its rendering. Unreal renders any object almost perfectly because it utilizes tech like nanite that can allow the geometry count of an object to be extremely high.
And is more than 33 million triangles.
Think of this. You can basically build anything you want with the highest polygon possible, and Unreal will do its thing. Can you do this in Godot? Well, not yet. For those watching, the Godot engine has always got heat for not having the best tech when it comes to 3D graphics. But even with Unreal having that tech, you wouldn't believe me how easy it is to fool some people into thinking something looks like it's made in Unreal when it isn't. That being said, I do appreciate all of the compliments that, that I've been getting. So let's start off with how I get good lighting. Now, this heavily depends if your scene is an indoor scene or an outdoor scene. Let's start off with an outdoor scene, since that's what the no-shop prototype looks like. You first grab a skybox. A skybox is just a sky wrapped in a box. No, like that's actually what it is. You want to basically swap out the default skybox and put this one instead. Now, as a former Unity developer myself, you're not gonna get good graphics immediately, unless you're using one of those graphic intensive pipelines. Well, I mean, like HDRP, it's trash, alright? It's trash. So yes, cry in that corner while I use Godot and show how it's superior. Oh. Anyways, sorry. Where was I? Yeah. If you change up the tone mapping mode to ACES, it makes sure your frame details are preserved and some emissive values are physically correct. Now we're kind of getting somewhere. So with all of this, we kind of have something decent, but it still looks like it's made by some 9-year-old acid flipper. Let's go back to no shot and observe what happens when we look at the sky. You can see how when the camera is facing directly towards the sun, the exposure kind of drops down. This is similar to how when bright light directly hits your eye, exposure from anywhere else drops down. Well, unless you're blind. This effect is kind of what makes the game looks pretty good when the player moves from a brighter area to a darker area. In Godot, this effect is called auto exposure. You can play with the settings to variate how much exposure you want and how fast it changes. That's pretty much step 1 done, but it still looks pretty meh. This is where you need to use volumetrics and fog. If you look at one of those forest scenes that you see in Unreal or any other good-looking game for that matter, you'll see these streams of light popping out of these small spaces. These are called volumetrics or God rays. Slap on that option in Godot and adjust some of the values. The density is what you want to play around with. You can easily see how much of a difference that makes to the overall look of the game. Just be careful, cause this can easily eat up performance. With that, you honestly have a pretty decent scene. Now, I'm sure you still might be whining and saying,
the scene may look fine, but my characters and assets look terrible. I know you weren't a professional game developer.
Shut the f up and calm down and let me tell you something. Okay, you may be right, but Let's say that you have a character in a scene and it's indoors. You don't even need all of these skybox shenanigans we talked about before. Well, it's possible to make it look good in Godot with just a little effort. First off, every model you want to export has to be to scale. If it's not to scale, Godot apparently has trouble with calculating the shadows for some parts of the mesh. You can see the difference in shadow quality between this export and this one that's scaled properly. You can then just apply all of the techniques we talked about before and you can get pretty decent results. Except there's one option you definitely would want if you're showing off things like characters. Ambient occlusion. Yeah, that was terrible, oh my god. Screen space ambient occlusion is a technique that calculates the AO in real time using the scene depth buffer. Now you don't need to know what that is, just know that it can have a good approximation of AO in real time. The difference with and without it is just quite insane for geometry that's complex. You might also be wondering how these reflections are done, which is odd because why would you want to look at your face? Well, first you have to turn on SSR, which is screen space reflections. And to step it up even further, we use Godot's experimental SDFGI. I would love to explain what that is, but I'm sure this is getting kind of boring for the average TikTok brain. I just turned it on because it looks cool and, makes things look good, but yeah. So SDFGI severely drops down your frame rate, like a lot. It's basically Godot's real-time GI system, and it can take up a decent chunk of your frames. You can still achieve pretty good results with it off, but if your computer can handle it, it can make things look real good. This also bumps up the way lighting affects certain surfaces and is especially useful for indoor scenes. But go learn all of that from dedicated tutorials because I really can't get into, the gimmicks of it. Alright, so we basically covered both lighting and rendering. How do we actually combine all of this and achieve the results NoShot does for some actual gameplay? If you don't already know, NoShot utilizes a bunch of post-processing to achieve the way it does look. And I've open sourced it, so if you want to use it in your own projects, go ahead. It basically contains a bunch of shaders that I've gotten from Godot shaders, which are also free by the way, and you basically layer this on top if you want to make it feel a lot better. A good example of this is a radial blur shader that I found that allows me to blur the frame. I use this whenever the player is moving at high speeds to give it more flair. There's a bunch more post-processing elements here that you should probably use depending on what you need. To use these, I basically made a post-processing system that allows me to call and change these values dynamically by code so that I can change them. When I was making games with Unity, I didn't even use any of the lighting stuff I talked about. The post-processing made the game look good. A lot of the stuff is fake to cut back costs and performance, and you can get away with a lot of stuff and people will think it's the real thing. I mean, seriously, these particle effects are really just images on a 2D plane just facing towards the camera. And you as the player just perceive it like it's almost the real thing. Not to mention texture maps. The surface detail on any mesh is done with a 2D texture called a normal map. It's basically all of the details carved onto a mesh on an image. Stack this on top of other necessary maps and you have something that looks pretty darn good. Everything else you see is just a little bit of game feel like screen shakes and sound effects, which by the way is just as important. You can't just make graphics good but then ignore the other stuff. But anyway, that's about it. And again, if you want to see more of how the project is done, I'll leave the GitHub link below. It's open source and you can do whatever the fuck you want with it. And you can watch my other devlogs because I made the whole project open source. You might as well. Also, I'll try to get the next devlog out soon. I've just been busy with college and for the past few weeks I've had exams and a bunch of college projects, so I haven't had time to make videos recently. Also, yeah, do let me know what videos I should post because I kind of want to pump out more content than going on 3 months breaks every time. I do want to post a lot more content, but I kind of want to balance out between these more technical and more fun ones. Anyways, I'll see you again in 2 to 3 months as usual. Wait, no, I think last time I said a year, but I think it's 2 to 3 months this time. Take care, bye-bye. Also, it has come to my attention that there's only 4% of you guys that are subscribed and 96% are not. Come on, guys, you can do better than this. I don't mean to sound like a YouTuber. I'm not asking for likes or anything, but support your boy. Yeah, this is totally not me dragging the video till 10 minutes because it's better for the algorithm.